Hi friends, welcome to Machine Learning Journey. This is lecture 10 of our ML series. So in this lecture, we will understand what does actually mean of learning in a machine learning. So in the previous lecture, we understood about linear regression algorithm. There we understood that for a given data, let's say you have one input feature and your output is Y, and you have that input output mapping is given. Okay, with this data, you assume that let's say y equals to mx, which is a linear line equation, will fit into this data and it will help you to predict on the unseen data. On the test data, it will benefit and it will create you a generic model. So here you will get best values of m and c. So there I explain about the errors. So uh, what the actual value it is given in the data and what you predicted. So the difference is the error, and I also explained about mean squared error, where you just square the difference and then taking the mean. Okay, summation, and then taking the mean of that error for all the values. So when you take error for a single value, single data point, then it is a loss function. And when you take when for values, all values or all data points, then it is cost function. This is the difference I should have told you before, but you just understand in the loss function, it is a single data point error or single data point uh, the difference of actual minus prediction. It can be square error also, whatever. And when you take mean for all the data points and sum it and divide it by total number of data points, then that is called cost functions. So now we will understand that when you say I have one column which is like actual and predicted. Actual is less than 10 and you predicted 12. Actual is 15, you predicted 18. Actual is 20 and you predicted 25. These are the values you know. So for each you have the error. You take the difference and you have the error. Now how you calculated? You got some value m x plus c. So how you start learning the machine learning models? So initially you assume some random value of m and c and calculated for training data, since this is the data which you are will be using to get the best values of parameter m and c such that it can fit into the data. So for step 1 you will initialize it with some random values, let's say 10x plus 20. 10 and 20 are the values you assume. Now you will go through each data points x comma y in our training data. Each data points you will fit into this equation and try to calculate the actual and predicted values. Now you will calculate the error. And what is your goal in the learning? The goal is learning is all about to reduce the error, the reduce the cost function, value of a cost functions. So what is a cost function? Let's say in the linear regression, we have used mean square error. Mean square error is summation of dividing by n and summation of 1 to n actual actual value minus predicted value for each data point I and taking it a square. You need to minimize this value, correct? So what you will do? You will assume some value m and c random, and then you will move towards such value of m and c such that the error reduces slowly. Sometimes you will reduce the m, sometimes you will increase the m, c, sometimes you will decrease both. So depending on the what the value you are getting. For example, let's say this is the y, which is a cost function. This is the cost function. Okay, just a second. This is a cost function, and let's say this is the m value at x-axis and y-axis is the cost functions. So for this m value, let's say this is the cost function you are getting at the different values of m. These are the different values of m you are getting. Now tell me which will be the best m value. The best m value where the cost function is minimum error. Cost function means minimum error. Minimum error is here when this m occurs. Let's say this is m dash. So m dash is the best value of m for which our overall cost function is less. This is the one parameter. Let's say now there are two parameters. This is y and this is m and this is c. Now you need to take such combination that this is, let's say, 2D graph. Okay, so 2D graph, and you need to figure out best value of m and c such that your error is minimum. Now these are the two parameters. Now suppose you have n parameters of a model, and what you will try to do with n parameters, initially you will assume some random values, then slowly you will figure out with some mathematical equations or some mathematical algorithm, which is known as gradient descent. In the next lecture, we will discuss. As of now, you just keep in mind that when you assume some model, you assume some parameters, let's say n parameters. For each parameter, you assume some random values, and you start with that random values and calculate the error with actual values and prediction values, and then try to reach such a combination of that parameters such that overall error for the complete data set reduces slowly. So depending on what kind of algorithm we will use, we will understand in the next lecture. But for now, you just understand that the model machine learning model is all about, like, initially you have data, you create model out of it, you make prediction. After prediction, you calculate the error. What is the error? You calculate the error for each point. You take the mean, which will be known as the mean squared cost function, which is also known as mean squared error. One of the example of cost function, mean squared error, used in linear regression generally. So this is the function. Now after that, again you will go back to the model, update the parameters with some mathematical intuition. Gradient descent algorithm, as of now, what it is, we will understand. But just remember, we updates the parameter such that this cost function reduces. Sometimes it doesn't reduces, it increases, sometimes it decreases, but we need to find overall which is the best. So overall, this is the idea. Just keep in mind that you have one, let's say, only one variable x input and y, which is a cost function, and you have this graph. Let's say you need to figure out x such that your cost function is minimum. Let's say initially you are sitting here. So here you know that this is the cost function you are getting, and this is the value of x you started at the step 1 or random initial. Initially you, with some algorithm, you initialize with some random values. Now you know that it can be reduced, so you reduce and you increase the value of x. You came here and the cost function decrease. Let's say randomly you reach the value here. Now again the cost function still decrease. Again you came to here, this point, cost function again increase for this value of x, for this value of x. Now you want to go back again. So here slowly you move towards downhill, and you reach the point where the cost function is minimum at what value of x. This is the one variable. Let's say this is one variable. Now if I say there are n variables, n parameters are there, and you need to figure out such value of n parameters such that overall your cost function or your error is reduced or minimum. It can be 100%. 100% error is reduced. Zero, your error is zero. Then your model is perfectly fine for your data, and you can test on the test set. And then if it works on test set also, then you can say that it is a generic data. There might be a possibility when you create a model, where it completely fits in the training data. Let's say this is the training data and you try to train the model, and your model comes out to be this equation, some sort of mathematical equation you created, such that when you give this value x1, this is the value, let's say inputs x3, x4, x5, s6, you give such values and you come up with this output. So this is perfectly fitting in the training data, so it will give the error equals to 0. But somewhere if I give here point, it may give some error. It will give some error. It will reduce some error, and it will not able to predict because it perfectly fitting in the training data, but it is not able to predict well on unseen data, which is a test set data. So that kind of model we will see is the overfit model. We will understand more on this lecture, more on this concept. But as of now, you understand that what is machine learning in the machine learning. Machine learning is all about reducing the error by finding the best values of parameter. This is what optimization all about. Okay, thanks for the listening. We'll meet in the next lecture.